Welcome to our deep dive into one of the most powerful and sustainable forces in the world of renewable energy, wind power. In this video, we'll explore how wind energy works, the technology behind those towering turbines, and why wind power is essential to our transition towards cleaner energy sources. Join us as we uncover the science, benefits, and potential of harnessing the wind to power our future. Get ready to feel the energy of the wind. Wind power, one of humanity's oldest energy sources, has evolved from humble beginnings into a sophisticated and essential player in the renewable energy landscape. For centuries, people have harnessed wind energy to sail ships across oceans, grind grain into flour, and pump water for irrigation. However, in the last century, the focus has shifted to converting wind into electricity, powering homes, industries, and entire communities with a clean, renewable energy source. Wind power, driven by the simple motion of air molecules, now stands as one of the most promising solutions to reduce our dependence on fossil fuels and combat climate change. To understand the significance of wind power, it's important to first consider what wind actually is. Wind results from the uneven heating of the Earth's surface by the sun. As sunlight warms different parts of the Earth, hot air rises, creating areas of low pressure, while cooler air sinks, resulting in areas of high pressure. These pressure differences cause air to move from high to low pressure zones, creating the phenomenon we know as wind. This movement of air is powerful and constant, especially in certain parts of the world where atmospheric conditions create reliable and robust wind patterns. The journey of harnessing wind energy begins with understanding this natural force and strategically placing wind turbines in areas where wind speeds are optimal. Modern wind turbines are technological marvels designed to capture even small amounts of kinetic energy from the wind and transform it into electricity. Towering high above the ground, often standing at heights of 80 to 140 meters, these turbines have long, aerodynamic blades that can measure over 60 meters each. The length of these blades is critical, as longer blades capture more wind, increasing the turbine's efficiency and power output. When wind hits the turbine's blades, it causes them to spin. This motion turns a rotor connected to a gearbox, which then increases the rotation speed. The energy from this rotation is transferred to a generator, converting kinetic energy into electrical energy. It's a beautifully efficient process that begins with a single gust of wind and ends with electricity flowing through power lines to homes and businesses. The simplicity of this transformation, from wind to electricity, demonstrates why wind power is a viable and scalable energy solution. One of the most appealing aspects of wind energy is its renewable nature. Unlike fossil fuels, which are finite and release carbon dioxide when burned, wind is an endless resource that produces no emissions during operation. This makes wind power not only environmentally friendly, but also a critical tool in reducing our carbon footprint. In fact, wind farms, the large-scale installations of wind turbines, can produce enough electricity to power entire cities, all while occupying relatively small amounts of land. The turbines themselves are highly efficient and can operate in a variety of climates and terrains, from offshore sites along coastlines to high mountain ridges and open plains. The versatility of wind power is further enhanced by offshore wind farms, which harness stronger and more consistent winds found over the ocean. Offshore wind turbines are typically larger and more powerful than their onshore counterparts, and they are strategically positioned to minimize visual and noise impacts on local communities. The energy potential of offshore wind is immense, with some countries already investing heavily in offshore wind farms as a way to meet energy needs sustainably. While offshore turbines are more costly to build and maintain due to the challenging ocean environment, their higher energy output often justifies these expenses. making offshore wind a valuable addition to the global renewable energy portfolio. Despite its numerous benefits, wind power does face challenges. The intermittent nature of wind means that turbines do not always produce a consistent supply of electricity, as output is directly tied to wind speed. When wind speeds are too low, turbines generate less electricity, and when winds are too strong, turbines may shut down to prevent damage. This variability poses a unique challenge for energy grids, which require a steady and reliable power supply to function efficiently. However, advancements in energy storage technologies, such as large-scale batteries, are helping to mitigate this issue by storing excess electricity generated during high wind periods for use during low wind periods. Wind power also encounters social and environmental challenges. Some communities have raised concerns about the aesthetic impact of wind turbines, feeling that the tall structures disrupt natural landscapes. Additionally, wind farms can impact local wildlife, particularly birds and bats, which may collide with turbine blades. However, ongoing research and development have led to innovations aimed at reducing these effects, such as improved turbine designs and strategic placement to minimize wildlife interactions. Many conservationists believe that the long-term environmental benefits of wind power far outweigh these concerns, especially considering the urgent need to transition away from carbon-heavy energy sources. In terms of economics, wind power has become increasingly cost-effective. The cost of producing electricity from wind has dropped significantly over the past few decades, largely due to advancements in turbine technology, economies of scale, and more efficient manufacturing processes. Today, wind power is one of the most affordable sources of electricity, often cheaper than coal or natural gas in many parts of the world. This economic advantage has made wind energy more accessible, encouraging both developed and developing nations to invest in wind infrastructure as part of their energy portfolios. As we move toward a future powered by renewable energy, wind power will play a crucial role in reducing greenhouse gas emissions and slowing the progression of climate change. Governments, organizations, and communities around the world are increasingly recognizing the importance of clean energy sources, with many setting ambitious goals to reduce carbon emissions and transition to renewables. Wind power, along with solar, hydroelectric, and other renewable sources, offers a pathway to a more sustainable and resilient energy system. Educational initiatives and public awareness campaigns are helping people understand the benefits of wind energy, leading to greater support for wind power projects. In many regions, communities are embracing wind farms as part of a shared commitment to environmental stewardship. Local economies benefit too, as wind farms create jobs, increase local tax revenues, and reduce dependence on imported fuels. This growth in community support reflects a broader shift in how we view and value renewable energy. In the grand scheme, wind power is part of a larger story about innovation, resilience, and responsibility. By harnessing the wind, humanity taps into a force of nature that has shaped our history and holds the promise of shaping our future. Wind energy represents not just an engineering marvel, but a shift in how we think about energy production, moving from extraction to partnership with nature. As we continue to refine and expand our use of wind power, we take another step toward a cleaner, more sustainable world, powered by the forces that have driven life on Earth for billions of years.